In summation, bowling is more of a sport than either, swimming or wrestling. Bowling requires more athleticism than either of those two. All right, here we go. I would never say anything bad about bowling. Cool. So, what was the name of our last section? Can somebody remind me? Hey, check it out. Here is 4.4, proving triangles congruent. Now, we could have just done one big section, realistically. It's typically split up over a couple. Your book doesn't actually call it this, but I don't want to give away all of the, no spoilers on this. So we're just trying to show triangles are congruent. Now, to start us off, on our bell ringer today, we did a proof, and that's all fine and dandy. Everybody loves proofs. I can dig it. But as we're looking at these, we are just going to keep expanding our shortcuts, and that's all that we're going to knock out here. So as we look at these things, our first topic, if you look back, you'll notice each of our main bullet points have been shortcuts so far. SAS was the first one, and then we did SSS. Cool. We get a new one. I'm going to go way out on a limb here. I want you guys to tell me. I'm going to write this shorthand over here first. What do you think this shorthand is? Raylene, I haven't heard from you today, or if I have, I don't recall. What do you think this is short for? Angle, side, angle, congruence. You've got it. Angle, side, angle, congruence. Now, just like the others, I have stupid little things that I remember. SAS, ASA is how I remember this one, and I do it with the extreme inflection. Don't know why. When I see this in my head, that's what I hear. Like, aha, but with ASA, I don't know. Anyway, what do you think we're about to write down? Because we're going to make this a theorem, like, immediately. Help me write the theorem. And this is theorem 4.6, and I'm just going to name it angle, side, angle, congruence. I'm going to give you guys like 30 seconds in pairs, and there's 6 people, so that works really well. Everybody can just look to your right behind you. Just kidding, only the first 3 row people can do that. You're going to see your partner. I want 30 seconds. Figure out what you think we're going to write for this theorem. I would rather just draw a picture, but I want you guys to see and say what the words are. If we have this, then the triangles are congruent. What is it going to be? Talk. I think this theorem is going to say, Vincent. How many angles between these 2 triangles that we're going to be comparing? 2 and a side, right? If 2 angles, and where's the side have to live according to the order we've written it? The middle, or between them. Is that what you mean by middle? If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are what? Congruent. Now, if you want the wordy version, I encourage you, the wordy version, page 177 if you want it. I think we can get by with a picture. Do you want me to make the triangles like change orientation, or can I just use the exact same triangle, exact same orientation? All right, so check it out. Here's 2 triangles that I guarantee indeed are congruent because I just copied and pasted. If I want these triangles to be congruent, let's name this. Let's say M, A, and T, and H. I want to be weird with this, but we won't. E, R. I really wanted to say math with an exclamation and a smiley face, but I'm not going to use an exclamation point and a smiley face for points. All right. Help me out here. I don't really care what we mark necessarily. Drew, give me a pair of angles that you think are congruent between these 2 triangles that I'm going to mark. T and H, you think? Oh, T and E. I agree. Here's one angle right now. Unfortunately, do we have a shortcut right now that's just angle? No, never existed. What else do I need, Raylene? Okay, which side would you like me to mark? There's 2 that work. There's 1 that won't work. So A is a point. Where's F?
Oh wait, T.
TM? I'll take TM. I was afraid you were going to try to give me this side at first. I'm glad you changed. Okay, hardest part. Anybody can answer this. The last angle that we mark has to be one of them. Specific one. M. Why M, Lily? Good. Angle, the next mark that we hit is the immediate next side, the adjacent side, and then the angle. We go 2, 1, 1, 2, 1, 1. And do you guys know what I mean by 2, 1, 1? 2 arc, 1 dash, 1 arc. Okay. What are we going to conclude about these two triangles then? They're congruent. Awesome. Deal. Easy enough to think about. Let's go ahead and write it out. I want my first one to be TAM. Triangle TAM. Tango Alpha Mike. Congruent to what, Andrew, if I go TAM in that order? So TAM. Love it. ERH. 1 blank double. 1 blank double. ERH is perfect, Andrew. Cool. So these two are congruent. Triangle ERH. Now, when I think about the proof of this one, and I would like to do it, we're presenting in a different order. We're not going to do it right now, but there is a way to prove it, just logically. Can you guys tell me anything else about these two triangles that we might be able to add? Hit it. A and R have to be congruent, right? Even before we get here, how do I know these are congruent? A and R. If these 2 plus 1 in blank adds up to 180, right? They have to. 2 plus 1 in blank add up to 180. They have to. These have to be the same number. A and R are the same. Now, at that point, we have angle, angle, side, angle would be the order that we go through. Now, we don't have currently everything that we need for it. Your book, they get around this by doing their proofs and saying, what congruence transformation would you move between these? I don't love that as a real approach to proving stuff. Hit it. Except there's a one side, we do. So you would have a hard time writing a formal proof with that logic, just because how do you justify that the rest of it is there other than saying it has to be? Like they are. I agree with you. Now, you might be trying to use, and we would ultimately use one more theorem to prove this. There's another theorem on top of it that we can get. You might recognize what that is. Maybe, I'm not sure, but cool. All right, we have this theorem. Are we cool with it? Okay, so for today, I'm going to try something a little bit different. Instead of just saying, let's do this and here's examples, we're immediately just going to put our next theorem, the second topic, and then we're going to do a variety of problems where we have to not only use one of these theorems, we have to decide which one is appropriate to use. Because if I just do a bunch of examples now, it's clearly going to be angle, side, angle. So we're going to try to expand this out and try it a little bit different. So immediately, we just get one more theorem today, and then the rest of class is just going to be examples and playing around with these. Cool. All right. So for our last one, remind me up to this point, and I'm going to keep writing these. This is probably something that should show up on your homework. But how many triangle shortcuts do we have for congruence at this point? We have 3 of them. Give me one, whoever. SAS stands for what? Side, angle, side, where it has to be between them, right? Give me another one. You know, in my head just now, instead of going to Harry Potter, do you guys watch Rick and Morty? Has everybody seen Rick and Morty? Have you seen the Snake Jazz episode? That's what my head just went to that time, which is kind of awesome. Anyway, one more triangle shortcut. ASA, angle, side, angle is our new one. We are going to reference these over and over and over and over. Be prepared. We get one more. Ray, I'm going to check your memory. Do you remember the last one?
I thought it was something like angle side or like angle side.
So we're never going to be asses, right? Did I make that joke in here yesterday?
Remember it 'cause
Okay.
it sounded like
Yep, and it does, and I don't, just so you know, if you do that, I really don't feel any like ill will or look down on you at all. But hopefully you remember that we don't use it as soon as you try to write that word on your page. Okay. Instead, what's it called in volleyball when somebody hits, they serve it and nobody touches it and you get the point? Angle, angle, side is our last one. Let's go ahead and just define it, and you'll see why I asked that other question. Angle, angle, side. And that's going to annoy me, but I'm not going to change that. Now, what are the letters that we would use to represent this? And I know that it might not be exactly how you would pronounce this, but can we all see where and why I might have asked you about what an ace is in volleyball? ACE is my last one. AAS, that's how I say it. Okay, for this, same thing. I think we would be okay if we don't write the wordy version. Does the order that I give these things in matter every single time? I think it does. It's mattered on each one of them, right? Like I could rearrange this to make it ASS, but I don't rearrange it. It has to be an angle and then a side touching it and then an angle. Okay, when we look at this one, I'm going to use the same triangles. So here they are. Here's one of them. And here's one of them. But this time, we're going to change the letters just so it feels a little bit different. And we'll also change what is given. So here we go. Let's say that this is ANG LES. That's fair. All right. Remember, to scale, mine's always, if I do it here and I copy and paste, it's going to be perfect, but the scale doesn't really matter. If I am going to use angle, angle, side, what do you think the wordy version of this is? If, what do I have true about these two triangles right off the bat? Okay, angles, two of them. Let's say it's N and E and G and S. Right now, with the marks that I have, if I will go between my marks, I go from an angle. What's the next mark I would hit? Angle. Even if I try to come this way, would I still hit an angle next? Whether I go this way, the first thing I hit next to it is an angle. But if I go to here and I don't hit anything and I keep going, I would still hit the same angle, right? Okay, here's the important part. Notice on two of ours, side, and angle, side, angle, we had the included side or angle. It was in the middle. This one's not. If I want to use angle, angle, side, where could I put the sides that are congruent? It's not between them. Could it be here at AG? Yeah, and I would still hit N, G, and then a side, angle, angle, side. Could it be here instead? Because I could still go angle. The next mark that I hit, the nearest mark, is an angle, and I hit a side again. It doesn't matter as long as it's the non-included side in this one. So, did you already mark yours? Doesn't matter if you already marked it. I'm going to mark this one. If I get this information, what do I conclude about these two triangles? They are indeed congruent. Triangle ANG is congruent to which, Vincent? LES. And if you notice and look closely, it says angles when we look at the name of all these, which is a fun geometry perk that we just got. Cool. All right. I'm going much faster. It might not feel like it. Can you guys tell that we're going way faster than normal? Does it feel too fast right now? Anybody's brains fried? Have I made you do other stuff to see how well you can control your own body? That's a weird question. It's not a weird question, but like, how on earth are you supposed to answer that? Have I made you guys put your hand up and move a circle away from you? Have we done that in here? Okay, good. You're looking at me like I'm crazy. We're going to do a really quick frame break. Cool. So we're going to do a bunch of random problems in here. You guys want to start with a proof? Okay. Then no would have been the appropriate response at that point in questioning, but I'm fine with that. All right. For these, it's pretty much all proof. All right, let's do one that's not quite a proof. Here we go. We're going to do some examples. And the cool part about this is that because we just said here are both theorems, we don't know which theorem we have to use. We have to decide, which is part of the struggle. So we now have a fourth one, SAS, ASA, and ACE. I don't know the appropriate thing. Remember, the one that you said is the one that we're not going to use ever. Cool. All right. I missed a total opportunity to pretend like I was going to send you to Miss Eustace for swearing in class. All right, let's do some problems. Nope, pink is for think. I won't do it in that color. White. All right. As we look at it, here we go. Oh, man. Okay, we got to draw two triangles. I just want, for this one, we're going to find x. And on A, I'm not going to use, like, you can use a straight edge if you want. I happen to use a straight edge only because I have stuff. I'm not going to label these triangles, I don't think. I don't know who continuously makes it so my door locks in the morning. I never, it's the very first thing that I do when I walk in the morning. Always, because I unlock it and then I flip it, because otherwise, the next time I leave, I slam into that door.
And consider that someone knows that this annoys you, and that's why they're doing it.
Is it you doing it? Because that certainly sounds like a guilty comment to me. ABC and PQR. Here's my two triangles. All right. Now, we're going to put a bunch of information in here. On angle Bravo, up here, 87 degrees. 87 degrees. Okay, on Q, 87 degrees, which that's convenient. All right, down on Charlie and Romeo, we get a cool 40 degrees. All right, then we know that PR is 9. It's feet, but I'm just going to call it 9. And then AC is, what do you think? You got it. That is 87 degrees, yes. All right, and finally, we know that AB, all the way over here, is a cool x plus 4 feet. And then on this side, it's a cool, let me think this out. No, that'd be too silly. How would you even find it if I wrote that? Because you're going to get 0 equals 0 if you solve it. Trying to think if I can make this work. X squared plus 6. And that's for this side. Now, I hope this works out real. I think it did. I just took the liberty to make this problem more algebra-y so that we get to use these skills more frequently than once a quarter. I'm stuck, and I don't know what to do. Help. Indeed. All right. What are my 4 shortcuts for congruence? Because if I have a reason to believe that AB and PQ are the same, I could just set these equal, right? But I can't do it just because they look like it. You have to be able to convince, and without any doubt, absolutely true, that these two are equal. Why would they be equal? Or how could we reach that conclusion? So I'll tell you, it's not. And I'm just going to commit to that. No more Slytherin. It's all jazz in my head every time for side, side, side. Do we have enough to say those triangles are congruent? Why? How? It is not side, 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 by the way. I'm going to put some marks on. Now, I know that the numbers are written, but marks will help. Those angles are the same, right? So we get an angle, so I know it's not side, side, side. These angles are the same. So I know it has 2 angles in it. Is there a triangle congruence has 2 angles? There's 2 of them. We have angle, side, angle, or ACE, angle, angle, side. Which one do we have here? Angle, angle, side. Because I go to an angle, my next mark that I would hit is an angle and a side. I'm going to mark that side. Tomorrow, bring your factoring hats because we're going to solve this. Tomorrow in class, we'll probably do 3 to 5 examples together. The rest of the time will be yours for homework and then making a note card because the next maybe day would be a quiz. All right, peace out. You guys have a wonderful day. Carson and Camille. Well, Camille, you'll be back. I mean, Carson, you'll be back too, but I hope your trip is going well. Don't forget, Carson, email me stuff when you watch this video. Cool.